Angular image capturing. With this in mind, our third and final integration sought to improve the images from tapering, working to implement image correction algorithms and new test metrics to find difference ratios with our histogram and increase our recognition efficiency. We created an Angular testing grid for deviating from the middle 20 to 80 degrees. Unfortunately, we were unable to move past the 50-degree mark from the hardware limitations of the glass. In conclusion, we found the glass easy to work with as Google has created an Android Studio programming application for integrating XML into Google Glass's cards. But as stated previously, the predetermined flaws of the glass hardware are the real bottleneck for creating a seamless augmented reality for the common user. I'll open the floor to any questions.
So what's the user experience like for this? They take a picture of someone the first time, and then every time that person returns it compares it against the original, or?
Well, we have a database that's set of 10 images.
Okay.
It's a histogram-like database, so it takes the image and it's going to analyze it with these 10 other images that are given
Right.
to the database.
Okay.
If I could ask, like, your Alzheimer's scenario, are you looking at, let's say, assisted living facilities where you're trying to kind of monitor people moving in different spaces? Or
Exactly, actually. So say you have like an Alzheimer's patient that might wander out of a ward. You can take his or her picture and realize maybe they're where they're supposed to be at, what medical needs they have, or what medicine they might be on.
where they, if someone sees them, where are they supposed to be?
Exactly.
Other questions?
This actually requires a very large database, right? So what's your thought on reducing the amount of data that's stored? Is there do you have an algorithm that you would run to reduce the data and then extract it and expand it? What,
So the SQLite offers data compression for our images and our data. So basically, we have it stored on an SD card or the local Android device. So memory isn't really an issue for our application, but it might be the quickness what we have to worry about, I guess.
Are you using a hub transform? What is the actual pattern matching strategy for the case?
We are using histogram, but the local binary pattern system.
So like going back to the question of data, like how much actual data do you need to like recognize one person? So like what's the actual like few megabytes? Like how big is it?
Good question. We ran a couple tests on how big the trainers that actually needs to be. Anywhere from 10 images down to 1 image. Just 1 image could be that viable training set for image recognition. As far as how much memory that takes, I believe it's less than, basically we just use a thumbnail as far as how many Google Glass processes the image. So this was probably less than 1 megabyte.
So using SQLite, storing it on the device, right? So SQLite is generally used with an Android device.